Ever feel like you're constantly putting out fires? Redoing work because of tiny errors, or just seeing the same problems pop up again and again?
Yeah, it's frustrating.
Or maybe you're just curious about how some of these top-tier organizations manage to get things right, like pretty much all the time. Today, we're doing a deep dive into operational excellence, and we're specifically focusing on quality and problem solving, using, well, a really powerful set of core principles and tools.
Right.
Our mission really is to unpack how you move beyond just fixing mistakes to actually preventing them, turning that chaos into some kind of control.
In this deep dive, it draws from some really foundational material. It lays out a systematic approach to achieving something that sounds almost impossible, zero defects.
Zero defects, wow.
Yeah, and tackling problems head on, not just, the symptoms. What's fascinating, I think, from these sources is how seamlessly prevention integrates with a really robust problem-solving framework.
Okay, so for you listening, whether you're working on a complex project, maybe managing a team, or honestly just looking to improve your own daily processes, we're going to start with what might seem like a pretty radical idea about quality. Then we'll explore some surprisingly effective methods for preventing errors.
All right.
And finally, we want to arm you with some powerful tools to identify and, importantly, correct problems right at their root.
Get to the source.
Exactly. Okay, let's unpack this. So when we talk about quality assurance, for many people, that probably brings up images of, someone at the end of a production line with a rubber stamp.
Yeah, pass, fail, that kind of thing.
Exactly, pass or fail. But our sources, they suggest something much more fundamental, almost a philosophical shift. What's this radical idea behind truly assuring quality beyond just catching errors at the end?
That's precisely it. The radical idea here is zero defects. And look, it's not just a slogan you hang on the wall, right? It's a foundational philosophy. The goal is explicit. It's like a triple promise. Don't make defects, don't pass on defects. Don't accept defects.
Don't pass on, don't accept. Okay.
Which naturally leads us to ask, what exactly is a defect in this context?
Good question.
And the sources give clear examples. Things like scrap material, offcuts, rejected products, or basically anything requiring corrections or rework.
Stuff you have to fix or throw away.
Exactly.
Yeah.
And what causes them? Well, often it's things like poor instructions, maybe inadequate training, issues with material quality.
Lack of maintenance, maybe.
Yeah, lack of maintenance, missing information, worn machine parts, even an incorrect design sometimes. Plus, lack of proper maintenance is a big one.
Zero defects. I mean, that sounds incredibly ambitious, almost utopian for complex systems. Is it really a realistic target, or is it more like an ideal you aim for?
It is ambitious, definitely, but the sources suggest it's absolutely a realistic target if you understand the philosophy behind it.
Okay.
And that's where this concept called zero quality control, or ZQC, comes in.
ZQC.
Okay.
Can you break that down? How does ZQC sort of transform the prevention game?
Well, ZQCC aims for zero defects by first recognizing something crucial. Machines and people will make mistakes. Errors are, kind of inevitable.
We're human. Machines wear out. Yeah.
Exactly. The genius of ZQC is that it finds systematic ways to keep those errors from ever turning into actual defects.
Oh, okay. So error doesn't automatically equal defect.
Precisely.
Yeah.
It's about building a process that's so robust, so mistake-proofed, that even if an error occurs, it just can't lead to a defect. It shifts the focus, you see, from blaming individuals, which is pointless,
right,
to perfecting the system itself.
Okay, so if we connect ZQC to the bigger picture, the benefits sound pretty compelling. What really stands out?
Well, first off, and maybe most obviously, it's paramount for maintaining customer satisfaction and loyalty. Nobody wants a defective product, right? But it also directly controls costs, because every single defect comes with a price tag, whether that's scrapping materials, reworking products, maybe even damaging equipment.
Hidden costs add up.
They really do. And for organizations aiming for, say, lean production methods with smaller inventories where every piece really counts, zero defects isn't just nice to have, it's essential.
Right. You can't afford waste.
Exactly.
Yeah.
Ultimately, ZQC assures that defective products are simply not produced in the first place. That's the goal. Not catching them later, but preventing them entirely.
Those benefits are clear. But let's play devil's advocate for a moment. Where do organizations often stumble when they try to implement something like ZQC? What are the common pitfalls?
It's a great question.
And drilling down even further, our sources pointed to 5 common culprits behind why errors even happen to begin with. What are those?
Yeah, you've hit on a crucial point. A common pitfall is misunderstanding ZQC. thinking it's about, like, instant perfection from day one. It's not. It's about building processes that catch and prevent errors before they become defects. It requires a pretty significant shift in mindset, which can be hard.
I could see that.
As for the causes, the sources outline 5 specific situations where defects typically arise. First, you've got inappropriate procedures or standards, like setting the wrong temperature for something.
Simple mistake, big impact.
Exactly. Second, excessive variability during operations, like too much play in a machine bearing, making things inconsistent. Third, using damaged or just excessively variable material, garbage in, garbage out.
Right.
Fourth, worn machine parts, old bearings, dull tools, that sort of thing. And finally, the fifth, and often the most frequent cause, simple human mistakes.
The oops moments.
Yeah, like, grabbing the wrong part, misreading an instruction. In a process, those small oops moments can snowball into major defects if the system doesn't catch them.
That really raises a critical question then. Are errors and defects the same thing? Because it sounds like the way you approach inspection dictates whether an error actually becomes a defect.
They are absolutely not the same, and that's really the core distinction ZQC makes. How we inspect determines the outcome.
Okay, so how do the sources differentiate between inspection approaches?
Right, so our sources highlight 3 main approaches. First, there's what's called judgment inspection.
Judgment inspection, okay.
This type only discovers defects after they've already been made, typically at the end of the process or maybe after several steps.
The old rubber stamp method?
Pretty much.
Yep.
And because of that timing, it doesn't reduce defects, it just finds them. It's purely reactive. Then you have informative inspection. This tries to overcome that timing issue by giving quick feedback back to the process that's actually producing the defect.
Okay, quicker feedback sounds better.
It is better. And there are 3 main ways mentioned. First, statistical quality control, or SQC. This checks samples of a product after processing, uses control charts, but it still kind of assumes some defects are unavoidable.
So it manages defects, doesn't eliminate them.
Right. Then there are successive checks. This is where people in the next process inspect each unit coming from the previous one, and they tell the previous operator immediately if a defect is found.
Peer review, almost.
Sort of. And finally, self-checks, where operators check their own work before passing it on. This gives even quicker feedback, but, it's hard for anyone to catch all of their own mistakes. But the truly revolutionary approach, the one that's crucial for ZQC, is source inspection.
Source inspection.
This is the only kind of inspection, according to these sources, that truly prevents defects. The real genius here isn't just catching errors early.
Okay.
It's the realization that you can stop them from ever becoming defects in the first place. It catches errors and gives feedback before processing or during processing in a way that stops a defect forming.
Before it's too late.
Exactly. And unlike SQC, which uses samples, source inspection often involves 100% inspection of every single unit passing through a critical point. And it uses a very short feedback loop for quick action.
And this is where something called Poka-Yoke comes in, mistake proofing.
Precisely. Poka-Yoke, these mistake proofing systems, are key tools for source inspection within ZQC. They're designed to physically prevent an error or halt production or give a clear warning the instant an error occurs. It literally makes it difficult or impossible for the error to result in a defect.
So it builds the quality check right into the process step itself.
You got it. It's not about being a better detective finding defects later. It's about being a better architect, designing a process where defects can't easily happen.
So, okay, judgment inspection just tells you messed up way too late. Informative gives you a quicker heads up, which is better. But source inspection, with things like Poka-Yoke, actually prevents the defect from happening.
That's a great summary.
Is it fair to say, then, that without source inspection, you're always sort of playing catch-up, always reacting?
Largely, yes. You're managing defects rather than engineering them out of the system.
Okay, so we've armed ourselves with this powerful mindset, 0 defects, and methods like source inspection to prevent defects. But let's be realistic, problems will still pop up sometimes, right?
Inevitably.
Or maybe we just want to continuously refine things, make a good process even better. So what's the playbook? What's the overarching strategy for tackling those challenges and driving improvement?
That's where the Planned Check Act cycle, or PDCA, becomes absolutely indispensable. It was popularized by Dr. Edward Deming.
PDCA, heard of it.
Yeah. And what's truly powerful here is its incredible versatility. It's a simple, yet really robust model for continuous improvement.
Okay, walk us through it. Plan.
Right. Plan. In this phase, you identify and analyze the problem. You ask questions like, is there a process throughput issue? Is our tact time really understood? You figure out what's wrong and plan a change or test.
Makes sense. Then
Right.
do.
Then you do. This means developing and implementing a solution, usually on a small scale first. Maybe creating adequate visual controls to identify problems if they're still happening. You execute the plan.
Okay, plan, do, check.
Check. This is crucial. You evaluate the results. Did the change work? Did those visual controls actually help? You measure and analyze the outcome of your do phase.
And finally, act.
And finally, you act based on what you learned in the check phase. If it worked, you might adopt the change, standardize it, update procedures. If it didn't work, you might abandon it, or maybe you need to cycle through again with a new plan based on what you learned.
So it's a loop.
Exactly. PDCA is great for continuous improvement, new projects, new designs, defining repetitive work, planning data collection, really implementing any kind of change effectively.
It sounds great, very logical. But where do people often get stuck in the PDCA cycle? Is there a common trap?
Oh, absolutely. A very common trap is getting stuck in the do phase. People love to jump to solutions. Right. Without sufficiently planning first. Or, even more frequently, people skip the check and act phases altogether. They implement something.
And then move on to the next fire.
Exactly. Without actually verifying if the solution worked or standardizing the change if it did, it breaks that cycle of continuous learning and improvement.
That makes sense. So assuming we don't fall into that trap once we're using PDCA, what are some specific tools we can pull out of the toolbox to make it really effective?
Great question. Because PDCA is the framework, but you need tools within that framework.
Exactly. Let's dig into some practical tools. First up, one you often see, the cause and effect diagram, or sometimes called the Fishbone Diagram.
Ah, the Fishbone, yes. It's fantastic, especially for structuring brainstorming sessions. It really helps teams explore much broader possibilities, especially when, thinking tends to fall into the same old ruts.
How does it work?
It helps you identify many possible causes for a specific effect or problem. And it immediately sorts those ideas into useful categories, typically things like materials, methods, people, measurements, machines, and maybe environment or design.
So it organizes the brainstorming chaos.
Precisely. It gives structure to creative thinking about causes.
Okay, then we have Pareto Charts. What's the hidden superpower of this seemingly simple bar graph?
Hidden superpower, I like that. The power of a Pareto chart is that it cuts through the noise. It visually demonstrates the 80-20 rule that often 80% of your problems come from just 20% of the causes.
The vital few.
Exactly. It's a bar graph where the lengths of the bars represent frequency or maybe cost, and they're arranged from longest bar to shortest. It immediately shows you which issues are most significant, helping you focus your limited resources where they'll have the biggest impact. Don't try to boil the ocean, focus on the big hitters first.
Makes sense. Prioritization. And another key tool mentioned is flowcharts. Beyond just mapping out the steps, what can these visual diagrams truly reveal about a process?
Flowcharts are often underestimated. Beyond just showing the sequence, a well-drawn flowchart can expose hidden loops, redundancies you never noticed, decision points that are confusing, or even steps that are entirely unnecessary.
So finding waste or bottlenecks.
Exactly. They graphically display the process steps in sequence, which helps identify critical control points, suggest improvements, and just makes it easier to explain or solve problems because everyone can see how the process is supposed to work or how it actually works.
Right. And of course, we can't forget simple brainstorming. Still a classic for a reason.
Absolutely. Brainstorming is great for just generating a large volume of creative ideas quickly.
Yeah.
Useful when you need a broad range of options or really original thinking, and you want that full group participation, that energy.
But sometimes brainstorming can be dominated by a few loud voices, right?
That's a common issue, and that's where a more structured version comes in handy. The nominal group technique, or NGT.
NGT. Okay, how does that differ?
NGT is basically structured brainstorming. It ensures everyone contributes, often through silent idea generation first, followed by round-robin sharing and structured voting. It's especially useful when, some members are more vocal than others, maybe some prefer silence to think, or perhaps the issue is controversial, or the group is new and needs that structure to feel comfortable participating fully.
Levels the playing field.
Exactly. Ensures all voices are heard.
Okay, so we've identified problems. We've got frameworks like PDCA, and we have tools like Fishbones and Paretos. But how do we ensure we're tackling the real reason something is going wrong? Getting beyond just the obvious symptoms. This feels like where root cause analysis comes in.
Absolutely. Root cause analysis, or RCA, is a methodology specifically focused on finding and correcting the most important reasons for performance problems. It targets those underlying issues, not just the surface-level difficulties.
Underlying issues, okay.
And this brings up a crucial point the sources make. What's the difference between different types of causes?
Ah, okay. There are different kinds.
Yeah, they distinguish between a few. First, you have presumptive causes. These are like your initial hypotheses, things that seem apparent at the start, but they really need validation with data.
Your first guess?
Kind of. Then there are contributing causes. These are factors that, well, they wouldn't cause the problem all by themselves, but that definitely played a part and probably need some corrective action.
Okay. Factors that made it worse or possible.
Right. And finally, the big one, the root cause. This is defined as the most basic reason for a problem. If you correct the root cause, the problem shouldn't happen again.
The fundamental reason. Got it. RCA sounds like detective work for processes. What's the structured approach? How do you actually do RCA to unearth these root causes?
It absolutely is like detective work.
Yeah.
The basic steps involve identifying all the possible causes, maybe using that fishbone diagram we talked about.
Right.
Then constructing the cause and effect diagram if you haven't already. Then, based on analysis and maybe some initial data, selecting the most likely root cause or causes. And crucially, verifying those suspected root causes with actual data. You can't just guess.
You need proof.
You need proof. Now, how do you find that root cause among all the possibilities? You start by constructing that cause and effect diagram to map everything out. Define the problem really clearly first.
Clarity is key.
Absolutely. Then develop that list of factors contributing using brainstorming, maybe NGT. Select your major cause categories like those 4 M's we mentioned: machines, methods, materials, manpower, or sometimes people use the 4 P's: policies, procedures, people, plant equipment. Doesn't matter so much which framework, just that you cover the bases. Then, to drill down for those categories to the actual root cause, you create the next level causes using a really powerful technique. The 5 whys method.
Ah, the 5 whys. Heard of this one too. Keep asking why.
Exactly. The counterintuitive insight here, often, is that the first or second answer you get to why is rarely the true root cause. It's usually just another symptom.
So you have to keep digging?
You have to keep digging. The 5 whys forces you to peel back those layers. The classic example is, why is there oil on the floor? Because the machine is leaking. Okay, but why is the machine leaking? Because the gasket failed. Okay, why did the gasket fail? Because we bought cheap gaskets. Why did we buy cheap gasket? Because the purchasing manager gets a bonus based on short-term cost savings.
Ah, now we're getting somewhere systemic.
Bingo. You typically ask why, maybe 3 to 5 times, sometimes more, until you hit that fundamental process or policy or design issue that, if fixed, prevents recurrence. It's not always 5 exactly, but you keep going until you hit that actionable root.
And you use the other quality tools alongside this.
Yes, you use the 7 quality tools like Pareto, flowcharts, check sheets, as needed throughout the RCA process to gather data, analyze, and verify. Once you identify the root cause, the final step is standardizing the fix into the work process to make sure it sticks.
The 5 whys sounds elegantly simple, but I can imagine situations where maybe it leads you down the wrong path if you're not asking the right whys, or maybe you stop too soon.
That's a really great observation, and it's a very common pitfall.
Yeah.
The biggest mistake is stopping too early, accepting a superficial answer, or, and this is critical, focusing on finding a person to blame instead of a process flaw.
Right. Pointing fingers doesn't fix the system.
Exactly. If your why sequence ends with, because Joe forgot, you haven't gone deep enough. Why did Joe forget? Was the process too complex? Was the training inadequate? Was there no checklist? The goal is to get to a systemic process-level root cause that can actually be fixed, something actionable that prevents recurrence for anyone, not just fixing one instance or blaming one person.
Okay, that's really helpful. Building on all that, the source material pulls these ideas together into a practical 5-step method for problem solving. It seems to weave together prevention, analysis, and action. Let's walk through that, maybe connecting it back to everything we've discussed.
Absolutely. It's a good way to structure the whole approach. Step 1 is simply identify and define. You have to clearly understand what the problem is. Be specific, no ambiguity allowed.
Get clear on the what. Okay. Step 2.
Step 2 is isolate and contain. Once you know what the problem is, you need to stop the bleeding, basically. Prevent the problem from spreading further and impacting other areas, other customers, other processes. Put up a temporary barrier if you need to.
Containment. Makes sense. Step 3.
Step 3 is collect and analyze data. This is where you move from anecdotes to facts. Gather information on the problem's frequency, its impact, where and when it happens. You might use tools like tally sheets or check sheets here. The example given was tracking Monday cut errors by type, wrong length, wrong angle, etc. This data helps you understand the scope and prioritize.
Data drives decisions. Got it. Step 4.
Step 4 is correct and reduce the problem. Now it's time for action. You use brainstorming, maybe NGT, maybe your Fishbone diagram and your 5 whys analysis to figure out the root cause and develop solutions. And crucially, this is where you aim to mistake-proof the process, bringing back those ZQC principles.
Poka-Yoke again?
Exactly. Re-emphasizing Poka-Yoke, error-proofing. Remember, they serve 2 purposes. They can provide 100% inspection right at the source, and they give that immediate feedback for corrective action. True ZQC really relies on Poka-Yoke built into source inspection. The example given was those petrol pumps with breakaway hose couplings that shut off the fuel flow instantly if someone drives away.
Prevents a spill even though an error occurred.
Perfect example of mistake-proofing in action. So step 4 is about implementing those kinds of fixes. And finally, step 5 is monitor and document the change. You can't just implement a fix and walk away. You need to continuously monitor the process to ensure your actions actually had the desired results. Did the problem go away? Did it decrease significantly?
The check and act from PDCA, essentially.
Very much so. Once you've verified the problem is eliminated or reduced to an acceptable level, you document the new process, the new procedures, and you train the staff. This locks in the improvement and ensures everyone follows the new, better method consistently. Prevents the problem from just creeping back in later.
That's right. And as you said earlier, this entire 5-step process isn't really a one-and-done thing, is it? It's a continuous cycle, like the PDCA loop.
Exactly. Once one problem is successfully addressed and a new standard is set, other opportunities for improvement inevitably emerge. Or maybe the next biggest problem becomes visible now, and the cycle just begins anew. It's all about that culture of constant, never-ending improvement.
Wow. We've covered a lot of ground today. We've explored everything from that really radical goal of 0 defects and the transformative power of things like source inspection and Poka-Yoke, all the way to overarching frameworks like PDCA and specific tools for root cause analysis like the Fishbone Diagram and that powerful 5 whys method.
Yeah, it's a comprehensive toolkit. And what truly stands out, I think, from this journey through the material is that this pursuit of quality and problem solving.
Yeah.
It isn't just for big manufacturing lines or, complex industrial processes.
Right.
It's really a mindset that applies to any process in any setting your office work, your personal projects, anything where you want to eliminate waste, improve reliability, and just continuously get better.
So it's broadly applicable.
Absolutely. And this brings up an important question maybe for you listening right now. How might just one of these principles, maybe the 5 whys, or just that simple don't make, don't pass on, don't accept philosophy, how might applying that transform some frustrating hassle in your daily work or maybe even in your personal life?
That's a great question to ponder. Think about that. Maybe identify one small frustration and try asking why a few times. See where it leads. How could you start applying these ideas not just to your job, but really to anything you want to improve?
Yeah.
This has been a deep dive into quality and problem solving. Really fascinating stuff. Until next time.